Our next speaker is Jim Thomas. I've known Jim a long time, actually. I think Jim was probably my first boss when I started at IPO in Bath. IPO is a big software house in Bath. Jim was eventually Chief Technology Officer there, but joined TVS recently as our Director of Software Testing. And Jim's going to speak about shifting left. Okay.
Right, thanks, Mike. Well, the bar's been set fairly high by those first two talks, so it makes me a little bit nervous standing up here now. But I'm here to talk to you this afternoon about shifting left, a more intelligent direction. Just out of interest, how many people have come across the term shift left in a testing context, not a bit shifting context? Okay, not that many, but those of you who have, hopefully I'll cover what you already know or maybe give you a bit more information. So shifting left is actually a number of the larger IT services companies are starting to talk about it now and using terms like radical and innovative and so on. But actually the concepts go back a long way, and it really is all about eliminating errors early. So shift left, the term, was actually used in an article in a testing context by a chap called Larry Smith in an article in Dr. Health Journal back in 2001. And what he was talking about really was his experiences of combining development and quality assurance stroke test earlier and much more deeply in the software development life cycle and the positive benefits of doing that. What he found, he was used to working in an environment where there's very much a development team developing software, throwing the software over the fence effectively to a QA test team who would then test it, find defects, feed the defects back. What he was finding, that's a very slow, quite expensive, inefficient process. And he got the opportunity to join a project very early on day one, a new project. He jumped at the chance of doing that. And the article is really about his experiences of working in that way from day one as a tester on a development project. And what he found was he was actually a number of things. First of all, he is able to start working on the test specification, as the development team were writing the functional specification. And that provided a number of benefits. He was helping them verify the functional specification, helping them ensure it was testable, rather than waiting till the end to find out there were problems with it. He was also able to influence the design of the software, actually building in facilities so that the software was actually easier to test. And that's a fairly important point. I've seen that a number of times where people don't really think about how they're designing software, and then it makes it really hard to test when they get to the test stage. He also found that he was able to get on with actually writing the tests as the developers were actually coding up the software. And because he'd done a lot of work early, he was actually able to help the developers. He was actually putting effort into writing unit test cases as well. So he ultimately found a number of results. First of all, a significant number of bugs or defects were actually found much earlier when we all know they're cheaper to fix and correct. It saved a lot of time by working in parallel, so actually doing a lot of the test work while the development work was carrying on. It saved resources both in terms of manpower and actually using equipment because he was working in a single team effectively. The code produced was actually easier to test, and it speeded up bug fixing. He was there working with a team in a collaborative environment, actually speeded everything up. Ultimately, did more testing overall, and last but not least, he felt far more motivated by the experience. He'd come from an environment where sometimes the test QA department was seen as a bit of a second-class citizen compared to the developers. And on occasions, there was a bit of an adversarial relationship between the development team and the QA test team. Working as part of a team, he felt much more valued. There was a far better environment in terms of collaborative working. So shift left is really all about why do we do this? Why do we wait until the end, until we find a large number of defects at the end of the software development life cycle, feeding them back because we found defects in requirements, high-level design, low-level design code, and all the rework associated with that. And again, I've seen instances where the amount of rework has been quite large, significant parts of the software having to be redesigned. On occasions, all the software having to be redesigned. On a couple of occasions, the contract cancelled because the software was never going to work. So shift left is really all about, well, why don't we actually spend more time verifying and validating requirements at the requirement stage, verifying the high-level design at the high-level design stage, the low-level design at the low-level design stage, and code at the coding stage. So when it actually comes to development test and acceptance test, we still find defects, but far fewer defects. It's as simple as that. Unfortunately, it doesn't always happen in practice. Even where teams think they're actually doing that, it doesn't happen. Doing it effectively really does require far more effort, time, and cost up front. And there are a number of techniques. Shift left isn't about using particular techniques. But there are a number of techniques which can be used. Formal inspections, reviews, peer reviews, benchmarking, prototyping. A lot of people do that to help validate requirements. Should be doing that as well if you've identified the technically risky areas of the design. You should be prototyping, benchmarking, modeling those areas as well. A lot of people don't spend enough time on that. Static analysis is another thing that, again, you can actually check whether the code is actually written to standards. You can find errors in the code, and more recently, the static analysis tools actually will identify security weaknesses in your code as well. There are tools for that. And importantly, as I said earlier, earlier test QA involvement actually helps improve testability of the requirements and the design. So there is more effort, time, and cost up front needed to do that. But what you actually get is improved requirements and design, earlier test specifications, more collaboration, and actually better motivation. Because ultimately, people actually prefer, in my experience anyway, working in an environment where the focus is on defect prevention rather than continually fixing defects that are found in test. And shift left is actually a little bit more than just shifting everything left, test and the verification activities into design and coding and requirements. You can actually be more intelligent about how you actually test software. Now, in my experience, if you spend more time unit testing, and you can unit test, there are tools out there, Cantata's here today, that actually you can test units of software, wherever those units are, in isolation, and particularly if you've done the verification work up front and you've got confidence in your design, you've got confidence in those individual units have been tested in isolation to their specifications. You know that you're working with pre-tested components. So when you actually put them together into higher level components, wherever those components are, they integrate fairly rapidly. You're focusing on interface coverage at that point, making sure the interfaces are all tested. They integrate rapidly, and you can continue integrating by levels up until the full system. Unfortunately, what I've seen quite often, people will put all the software together in one go and try and test it up there on their 2-month or 3-month or whatever integration system test timescale goes out the window as they keep finding more and more faults. They find it really difficult to chase down faults by putting too much software together in one go. And what effective testing is really all about is building a pyramid of proof, so you've got testing at various levels. And it's surprising how quickly software will actually fit together if you do the verification up front and you do your testing in a structured manner. So shift left is really all about changing the balance, changing the quality balance. The focus is on building quality in, spending more time on verification, as opposed to trying to test quality in, identifying faults and having to go back and fix the software. There is a balance as well that people will ask about. Okay, that's great, but you're going to spend a lot more cost and time up front. Is it really worth the effort? Okay. Well, there's lots of statistics and data out there, and as Dot said, people don't always take it with a pinch of salt, but most of you probably have seen this. It's the relative cost of fixing defects in requirements as you go through the phases of the software development life cycle into operation. It becomes far more expensive to fix defects. So why do we wait till later on to find those defects when we could find them earlier? Some more data for you here. 40 to 50% of effort is actually spent on a project on avoidable rework. That is actually addressing software issues and problems which could have been detected earlier or maybe even avoided altogether. Peer reviews have been reported as they catch somewhere between 30 to 90% of defects. They're effective. but a lot of companies don't do any reviewing of independent reviewing of software. I think the median's around about 60%. I don't know if you can read that, but personal practice can reduce, this is actually defect introduction, can reduce defect introduction, a developer introducing defects into their work. Personal practice can reduce it by up to 75%. If you just focus people on actually focusing on quality and actually checking what they do instead of time, they can actually significantly reduce defects in their own work. And a few more stats for you. This comes from the Software Quality Survey 2012, which is an annual survey. It's reported by Capes Jones. For 2012, what was reported was the best projects versus those average projects in 2012. They actually produced 6 times fewer delivered defects. And comparing the best to the worst is something like over 20 times fewer defects in comparison. Programmers, they found, have been less than 50% efficient in finding their own defects. So again, peer reviews can be very effective. When tools like inspection, static analysis, and testing are actually all combined, they can be highly efficient in removing defects. Not only that, whether you believe it or not, lowering costs and schedules and the total cost of ownership over the life of the system as well. There are challenges. First of all, as I said earlier, there's more work up front. Shift left can look expensive, and those project managers have put together project plans which are a little bit lighter in the requirements and design phase, and on paper at least promise to deliver earlier. Yeah, that can look good. So that is a challenge in itself. And there's always pressure to deliver software. And because of that pressure and the need to actually get into coding very quickly, requirements and design are often rushed, and it's certainly my experience. Inspections and reviews, for people who are not used to them and are not used to working in a collaborative, open environment, they're not popular. It takes time to get used to. And development testing is often too ad hoc. People are actually maybe doing unit testing, but no particular criteria, so the actual quality of those unit tests are quite variable. And finally, test and QA has become a bit of a developer's crutch because people know the software is going to be tested, isn't it? So well, we don't need to spend too much time actually getting rid of defects. We're going to throw it across to the testers, and they'll find them for us. So what's really needed is a mindset change. People start thinking about taking responsibility for the quality of their own work, improving the quality of their own work, and actually thinking about, yeah, we want to work in an environment which is about defect prevention rather than spending all our time fixing defects. I just want to finish with, this is actually based on a couple of real projects, comparing a couple of real projects developing broadly similar amounts of software for a particular organization. Project B, which is the one at the back there, they ramped up fairly quickly. This is timescale and resources on the vertical axis. They ramped the team up fairly quickly. They went through requirements fairly quickly. They shot through design, and they were soon into coding, spent a lot of time coding. At this point, they started hitting issues with requirements. They hit a lot of issues with design that should have been addressed up front, but wasn't. It took time to actually remove those issues. They actually delivered late, and when they actually did deliver, the software itself had a reasonable number of defects, so there was a defect removal cycle and a further release and a further cycle until the software was stable. In contrast, Project A actually ramped up much more slowly. There's fewer people, but they spent a lot more time challenging and questioning and validating requirements, doing the same with the design, things like actually tying down external interfaces and so on, and insisting on that up front. They ramped up to actually more people, spent more time on code and unit test, but they found integration and acceptance was actually relatively quick, and they were pretty much on time and delivered an order of fewer, less defects. And when we looked at the amount of effort that went into the two projects, there were about 40% less effort went into Project A, and as I say, an order of magnitude less defects actually delivered. So shift left, I hope you can take a few of these things away. Shift left isn't actually that new. In fact, it goes back to the 70s, the idea of actually eliminating errors early in the development life cycle. The focus really for the shift left is about building quality in, bringing testing and more intelligent testing into the development phase. Inspection, review, static analysis, and more intelligent testing can all be very highly effective. So ultimately, you can get better quality faster and cheaper as well. Okay, thanks, Mark.
we have time for one or two questions. Nick?
Thanks, Mike. Thank you, Jim. My apologies, is probably almost a philosophical question, but on your pyramid,
Yeah.
I think we can acknowledge you're never going to have 100% bug-free code.
No.
And then when you start building up your pyramid, you have a pyramid of defects.
Yeah. Yeah.
At what point is it, or do you think is an acceptable level of defect for those pre-tested components? Because the bigger the pyramid, the more problems you'll actually potentially have. I agree it's better than what we do at the moment, but even so, you have to have some constraints.
What I'm talking about is when you actually start, if you're doing unit testing and things, new development concepts like that, well, not that new really, but agile, I actually encouraging people to do unit testing. If you're doing it effectively, what you can do, and going back to Giles is talking about constrained testing and covering more test cases. If you focus on your unit testing, this is obviously done in safety-related area anyway, you're focusing on statement coverage and decision condition coverage, complete coverage of those at a unit level, which you can do. You're dealing with a small amount of software. So there are still defects, but you're actually ensuring you're covering the greater amount of the software. So by the time So what I'm talking about really is you've got pre-tested components, you've got a high degree of confidence in those components. When you put it together into a larger lump, wherever that lump is, a task in a multitasking system or a thread through a multi-tier system, then you're actually you're fairly confident that what you're primarily looking for are interfacing errors. So you're doing interface coverage. So ultimately, you can build your software up by level, and you actually you will find that you actually rapidly go through those testing levels. It's far more predictable. So there's still defects, but you will find there are fewer defects compared to.
I'm sure you've just said fairly confident and high level of confidence.
Yeah. It's not, you're not eliminating defects.
No, and it's the law of diminishing returns as well. You'll never get rid of them. You spend more money to test them. Are we talking 70%, 80%, 90%, 99.999%?
Well,
what's your high level and high enough?
High enough. Well, in the high 90s, as I said there, things like. I wouldn't recommend that all you do is just focus all your time on testing. You should be using other techniques like reviews, inspections, and so on, and static analysis tools. Again, it's all a bit of a cost judgment because all these tools cost money as well. You could be using open source, of course, but even that there's a cost involved in training people. But in combination, you should be up in the very high 90s, over 99% in terms of removing defects. Good questions.
Thanks, Nick. One last question, and then I think the tea and coffee is ready. You can pass it on, actually, Nick.
Hi.
Hi.
I'm a tester, and I agree with pretty much everything that you're saying, but is it not basically the ICEF waterfall method?
Well, what was shown there was the waterfall method, and a lot of projects still follow that method, and I've been involved with lots of projects over the years, and it gets a bit maligned, the waterfall method or the V model, in that I've been involved in lots of successful waterfall V model methods, but it's not exclusive to that. You can still be, in fact, shift left isn't agile, but obviously many aspects of agile are implementing aspects of shift left in terms of involving users, so you're validating requirements. You've got a very short sprint cycle, so you're actually getting feedback on requirements effectively more frequently. So Agile is actually, there's a lot of shift left in Agile, although they're not the same. But it doesn't mean, though, even if you're in an Agile environment, you shouldn't spend time actually reviewing code and removing bugs at that level. Obviously, there is a strong focus on automated unit tests in Agile, because you're releasing all the time and you want to have those regression tests. But again, you can write those unit tests badly or well, and so if people actually spend a bit more time on understanding what verification they're doing, you can still improve even in an agile environment. Shift left can still apply.
Okay, thank you very much, Jim.